Welcome back to part 2 of the 6.2 notes. We're going to pick up where we left off and just take a look at example 4. So here we want to write the equation of the tangent line to y equals x e to the x minus e to the x at the point 1, 0. Well, you want to think about what do you need to write the equation of a tangent line. You need slope and you need a point. We've got a point. So basically we need slope. So to find the slope of the tangent line, we're going to take the derivative of the function. So be careful, because when you take the derivative of x e to the x minus e to the x, you have to recognize that x e to the x right there is a product. So we're going to have to use the product rule. So the derivative of x is 1 times e to the x plus the derivative of e to the x is e to the x times x. So that's x e to the x. And then the derivative, so it's going to be minus the derivative of e to the x, which is e to the x. All right. As you look at that, the 1 e to the x, the negative e to the x, they're going to cancel. So the derivative is x e to the x. Now, because we're trying to find the slope of the tangent line at a given point, we're going to need to evaluate the derivative at 1. So y prime of 1 is 1 e to the 1, which is going to give us a value of e. At that point, you've got your slope, right? This is the slope of the tangent line. You've got the point that was given up here. We can write the equation. So y equals e times x minus 1 plus 0, which can just be simplified to e times x minus 1. Or you could distribute the e and have it be in slope-intercept form. But again, no real need to do that. Just remember, guys, anytime you see a question asking you to write the equation of a tangent line, you need slope and you need a point. Slope of the tangent line is going to be the derivative of the function. All right, let's look at integration now with bases other than e. So the first video mainly focused on integrals of functions that had base e. So the integration rule for exponential function with bases other than e says the integral of a to the u du is equal to 1 over the natural log of the base times the function plus c. So 1 over natural log of the base times the function plus c. If we apply that to below, all right, we've got the integral of 5 to the power x. So our, that is set up as an exponential. Our base is not e. So the integral is going to be 1 over the natural log of the base times the function plus c. At that point, we can simply, rearrange that and just go 5x over the natural log of 5 plus c. And that is it. All right, let's go to the next page. Take a look at the next few examples. Again, I probably should have mentioned this before, guys, but pause the video if you need to. Or not if you need to, but I would pause the video, try the problem, and then see how we do it. So if we take a look here, we got the integral of negative x times 4 to the x squared dx. Again, no product rule, no chain rule when we deal with integration. So we want to let u typically be the inner function, which in this case is x squared. So du is 2x dx. Now, we don't have 2x dx, we have negative x dx. So what we want to do is we want to actually divide by negative 2. So we're going to get negative 1/2 du is negative x dx. At that point, substitute in, we've got negative 1/2 times the integral. The negative x dx is going to get replaced with the negative 1/2 du. The x squared is going to get replaced with the u, so this is 4u du. All right, at that point, we can apply the formula. We've got negative 1/2 and then times. 4 to the u is an exponential with a base other than e. So we have 1 over the natural log of the base times the function plus c. At that point, you are going to substitute your x squared back in. So if you just did it here, you could write that as 4 to the x squared over ln of 4 plus c, which would be okay. You might see it written as negative 4 to the x squared over 2 ln of 4 plus c, which again is okay. Or what you possibly could see as well as negative 4 to the x squared over the natural log of 16 plus c. Just making sure we understand equivalent forms. All right, and where the 16 is coming from is we have a rule with logs where, it's basically the power rule, which says we can take this 2 that's in front and make it the power here. So this is ln of 4 squared, and of course 4 squared is 16. All right, so let's take a look at example number 3. We want to do the integral from 1 to e. So now we have a definite integral of 6x minus 2x. So because we have a difference, all right, the integral of a difference is the difference of the integrals, but we can do this all at once. So let's go ahead, and if we take the integral of 6x, we're going to get 1 over the natural log of the base times the function, minus, when we take the integral of 2 to the x, we get 1 over the natural log of the base times the function. We are evaluating from 1 to e. So now, at that point, you got to kind of think about what's going on. Well, we've got, 6 to the x, or 1 over ln of x times 6 to the x could be 6 to the x over ln of 6. So when we substitute in e, I'm going to write this as 6 to the e over ln of 6 minus 2 to the e over ln of 2. And then you're subtracting, okay, because that's basically evaluating the upper limit, and then you're going to subtract the lower limit, which is going to be 6 ln of 6 minus 2 ln of 2. One thing you could do, change that to plus, change those signs, and then combine like terms with the terms that have the common denominator. So you could have 6 to the e minus 6 over ln of 6, and then it would be minus 2 to the e plus 2 over ln of 2. And that is your answer. All right. Guys, there are some extra problems here if you feel like you need a little bit of additional practice. Let's see where we're at. I was trying to check the time on the video to see what we have. Let's go ahead and just quickly go through these and do them. That way, if you need to see them, at least they're done. If you need them, though, I would recommend that you try them on your own first and then go from there. So looking at 1, I can see there's a function within a function, so I'm going to go ahead and let u equal 5x squared minus 1. So du is 10x dx. We've got x dx, so we're going to get 1/10 du is x dx. So as we come back over here and we substitute, you've got 1 over 10 times the integral of e to the u du. So the integral of e to the u is e to the u, so this would be 1/10 e to the u plus c. And the only thing really left to do is to resubstitute. So 1 over 10 e to the 5x squared minus 1 plus c. All right, if we do number 2, again, kind of the same idea. We got to figure out what goes where. This one's not as obvious maybe, but a lot of times with fractions, you want to let the denominator be u. So let's see what happens when we do that. If we let u equal e to the x, minus e to the negative x. Du is e to the x plus e to the negative x dx. And if you look at that, there it is. All right, so we made a good decision with what we chose for u. So at that point, we're going to get the integral of 1 over u du. And the integral of 1 over u is natural log of the absolute value of u plus c, which if we go ahead and substitute back in, you've got ln of the absolute value of e to the x minus e to the negative x plus c. All right, and if we were to go and take a look at the next example, and sorry, I just want to check my time, make sure this video is not too long. Okay, so if we go look at example 3, we've got x times 4 to the negative x squared. So inner function, again, is that negative x squared. So we're going to let u equal negative x squared. Du is negative 2x dx. We have x dx, so we're going to divide by that negative 2. So negative 1/2 du is x dx. We can go ahead and substitute at that point. This becomes 4 to the u du. And if we integrate, we've got 1 over the natural log of the base times the function plus c. And then, whoops, we want to, again, we're doing indefinite integrals, so we want to go back and resubstitute to the original variable. So this could be negative, and then 4 to the negative x squared over 2 ln of 4 plus c. And again, because of that 2 in front, you could make it the power of 4 and get ln of 16 on the bottom. Again, not required, but it's possible. All right, last one we've got here is we've got 7 to the power sine of x cosine of x dx. So what we're going to go ahead and do here is we're going to let u equal that inner function sine of x. Du is cosine of x dx. And there is that cosine of x dx. So we've got the integral of 7u du. All right, all we got to do is apply the rule for integrating exponentials. So it's 1 over the natural log of the base times the function plus c. And then go ahead and resubstitute sine of x back in for u. 7 to the sine of x over ln of 7 plus c. And we got it. All right, hope you guys found these videos useful. Make sure you check out the next videos. But that's it for 6.2.